First one is talking about just a rotation of a wheel. It says a nail is caught in the tread of a rotating tire at point N in the following sketch. So this graph is sketch 4 here. Is rotating, and as it rotates, the nail is going to take a path that, goes up, hits the ground here, comes back up, and so on. The tire has a diameter of 50 centimeters and rotates at 10 revolutions per minute. After 4.5 seconds, the nail touches the ground. Use the information to write a scale for each axis. So thinking about this information, present our time in seconds, so how fast the nail is moving or how fast the tire is moving. And then this is going to represent the height of the nail in terms of where it is in terms of the tire. Okay. So a scale for our vertical is, well, it says the diameter of the wheel is 50 centimeters. So this diameter of the wheel is 50. So this halfway point would be 25, and this maximum point would be 50. And obviously this would be 0. And then we need to write a scale for our x-axis. So this comes from basically our period. We need to figure out, if we would do one cycle of this, I'm just going to sketch in my central axis here. I want to figure out the period of one rotation. So how fast it takes to rotate for the nail to go through one cycle, right? One full rotation. So it says here it takes 10 revolutions per minute. So if I take a full minute, and I wrote that in seconds, so 60 seconds. So in 60 seconds, that's going to take rotations. I'm doing 10 rotations in 60 seconds. If I divide this by 10, this will give us our period. So one rotation is going to represent 6 seconds. So this point here would be 6 seconds. So that means our halfway point here is going to be 3 seconds. That means the halfway point between here and here is going to be 1.5, and the halfway point between here and here is going to be 4.5. And then if we wanted to continue 12, this point here would be 9. Okay, so there's our scale. It says determine the equation for the height of the nail as a function of time in the form h of t equals a cos of t minus c plus d, where a has to be greater than 0. So it's telling us that our a value has to be a positive value. So this means we are not going to have a reflection happening. So we're not going to consider a reflection in our equation. So let's here. So our a value, we know, is going to be our maximum minus our minimum, which is 0, divided by 2. So 50 divided by 2 is 25. So our amplitude would be 25. Our b value comes from the period by taking 2 pi and dividing by our period. So this is going to be simplified to pi over 3. So our b value would be pi over 3. Our c value I always tend to do last because that's the hardest point. Our d value is our central axis. Well, we already drew our central axis in. It's pretty obvious that it's halfway between 0 and 50. It would be 25. And then our c value is our phase shift. So remember, if we are working with a cosine graph, we are looking for at what point our maximum has moved off the y-axis, because normally our cosine function, our maximum is on the y-axis. How many units has it moved over from the y-axis? And looking from our scale here, this has moved over 1.5 units to the right, so a positive 1.5. So what would our equation of this, the height of the nail, be? 5 cos of pi over 3 is our b value, times t minus 1.5 plus 25. So if we graph this on our calculators, okay, we would get this exact same graph, okay, with roughly the same windows. So how far to the nearest tenth of a centimeter is the nail above the ground after 6.5 seconds? So we can see by substituting the 6.5 seconds in for our time and solving for our height. So I'm going to find the height at 6.5 seconds. This is going to equal to 25 cos of pi over 3, 6.5 minus 1.5 plus 25. So you can type this all into your calculator pretty much exactly how you see it. Make sure your mode is on radian mode, which it is. And I'm going to type in 25 cos of pi over 3. And then I need a second set of brackets, 6 minus 1.5. Close my 2 sets of brackets, and then I'm going to add 25. And my answer should be 37.5 centimeters. Okay, and then the last bullet, determine the equation for the height of a nail, of the nail as a function of time in the form b t minus c plus d, where a is less than 0 now. So they're telling me that this has to be, there has to be a reflection in the x-axis. So the only thing that is going to change in our function is our phase shift and our a value. So our a value should now be 25. Our period is still going to be the same, so our b pi over 3. We're now going to figure out the phase shift, and our central axis is still going to be 25. So what we want to think about is, normally our sine graph starts here. Okay, and so normally we'd look for this point on the central axis in this direction, right? So really this hasn't moved at all, but the question is telling us that our a value is a negative value. So this tells me that this graph needs to be reflected in the x-axis. So I am no longer looking for the point where the graph is increasing. If I reflected this, I am now looking for this scenario where the graph starts on my central axis but is moving in the decreasing first as opposed to increasing. So if I go back up to my graph, I don't want this point, I want this point here, because from here my values are decreasing. So my phase shift would be 3 units to the right. So this would be 3. So that's how you would figure that value out. So if your a value is negative, you have to think of this as this has been reflected. So I'm reflecting my graph. So I'm now looking for this point where my graph is decreasing as opposed to my sine function in relationship to that central axis. Okay, and so that phase shift ends up to be a 3. Or technically we could have, if we envision this going this way, we could have said this would be a negative 3 as well. Okay, so technically this could be a plus or minus 3. Either of those answers would be 100% correct. Okay. All right, and then our last example, this is our classic Ferris wheel question that we see quite often. Okay, it says the first Ferris wheel ever built was created by a bridge builder by the name of George W. Ferris in 1893. The diameter of the wheel was approximately 76 meters, so I'm going to highlight this. And the maximum height of the Ferris wheel approximately 80 meters. It had 36 carts on the wheel, with each cart able to hold approximately 60 people. This sounds like a massive Ferris wheel. So every cart held 80 people and there's 36 of them. Okay, and it rotated to a height of 80 meters tall. So if the wheel rotates every 3 minutes, so this relates to our period, draw a graph which represents the height of a cart in meters as a function of time in minutes. Assume the cart is at its highest position at 0. So they've loaded the entire cart. You got on the cart halfway through and they've now have everyone on, so you would be starting at the highest position and rotating around when the actual ride begins. So show 3 complete cycles of this Ferris wheel. All right, so this is going to be our time in minutes. It says it rotates every 3 minutes. So one full rotate is going to take 3 minutes long. So let's say this is our 3 minute mark. This is our full rotation, and we want to rotate complete cycles. So we're going to go up to our 9 minute mark. And then we want to figure out the scale. So this is going to be the height of the Ferris wheel in meters. It says the diameter of the wheel is 76 meters. And the maximum height that you would reach on a person riding it would be 80 meters. So I'm going to put this way up here. If the diameter is 76 meters, that means I'm actually getting on the ride at a 4 meter mark. So there must be a platform with stairs that you have to walk up in order to get onto the ride at the 4 meter mark. Okay. All right. So now we're going to draw 3 complete cycles. So we have the time at 0 is going to be at the highest position. So our first point of this sketch is going to start here. I need to get back to that highest point after 3 minutes because it takes 3 minutes to do one full rotation. Okay, so that means the halfway point is going to be, I'm going to be at the minimum point. So halfway between 0 and 3 would be 1.5. Would be this point here. And then same thing between 3 and 6, I'd be at the minimum. At 6, I'd be back at the maximum. In between there, I'd be at the minimum, and I'd be back at the maximum. So then I'm going to draw my key points on my cell axis. So if you think about this being 76 is the diameter, 76.2, the radius of my graph is going to be 38, but then I need to add 4 to that to get my central point. So at the 42 meter mark is going to be my central axis. So you don't have to draw the central axis. I just like to get these 5 key points, and then these points on my central axis are going to fall halfway between the 0 and 1.5 mark and between 1.5 and 3. So what is my graph going to look like? It's going to go up and down. So there's 2 cycles. There is my 3rd cycle. Okay. Determine of the equation of the graph as a sine and cosine function. So what do we need to do? We need to figure out the amplitude. How do we figure out the amplitude? Maximum minus the minimum divided by 2. Or if you think about a wheel, the amplitude will always represent the radius of the wheel. And the radius of our wheel is 38. Okay. Or you could take 80, subtract 4, which is 76, divide that by 2, you get your amplitude. Okay, so our amplitude is 38. Our b value of our equation is going to be 2 pi divided by the period, which is 3. So 2 pi over 3. I'm going to do my d value. I'll do my c value separate because it's going to be different for my sine and cosine function. My d value is the central axis. Well, we've kind of already figured that out. In this case, our minimum plus the amplitude or we could have taken our maximum and subtracted the amplitude. Either way, we know that central axis is at 42. All right, let's do our cosine function first, because that's usually the easier one. Look, our cosine is starting at its maximum point, which a negative regular cosine function also starts at its maximum. So for a cosine function, there is no phase shift at all. So if we wrote this as a cosine function, h of t, height at time, function of the height of time, would be 38 cos 2 pi over 3, bracket t, there is no phase shift, and then plus 42 would be our equation. All right, sine function, a little bit different. We now have to consider a phase shift. So our a value is going to stay the same. B value does not change as well. We are now going to have a phase shift, and our d value will also stay the same. So phase shift, thinking about that sine function. Right, our sine function starts here in an increasing upward direction. So we want to look for where that point is on this curve, which would be right here. Or you could go backwards, and it'd be right here. Okay, so what you need to figure out is you need to figure out the halfway distance between 0 and 1.5, which is 0.75. And then I'm going to add this to 1.5. So 2.25. So that is our phase shift to the right. Or I could have went 0.75 to the left. Or I could have done a reflect in the x-axis and 0.75 to the right. So all options would be 100% correct. So I could have 38 sine of 2 pi over 3, t minus 2.25 plus 40. I'll just write the other equation here. Or I could have 38 sine of 2 pi over 3, t minus 0 or plus 0.75. So 0.75 units to the left. Or another option could have a negative 38 sine of 2 pi over 3, t minus 0.75 plus 42. All three of these equations might be a different answer for 3 students. All of them would be 100% correct. Okay, so when you're asked to graph the sine function, as long as you're picking the phase shifts that are closest to the y-axis, so one of these 3 points, all would be correct as long as your a value is correct in respect to that as well. How high is the cart 5 minutes after the wheel starts rotating? Well, I'm going to substitute 5 into any one of these 4 equations. I'm going to substitute it into my cosine equation just because that would be the least amount of work. So on my calculator, make sure it's in radian mode. Cos of 2 pi over 3 times 5 plus 4. My answer should be 23 meters. Okay, and then last question. How many seconds after the wheel starts rotating does the cart first reach the 10-meter mark? So 10-meter mark somewhere around here. I want to find this location. How many minutes has gone by, or how many seconds has gone by at that point? So I'm going to substitute, or I'm going to replace my height, and I'm going to show you how to solve this equation algebraically to get your answer. Okay, so what I'm going to do is I'm going to let theta equal this entire angle expression, 2 pi over 3t. So I'm going to solve this equation for theta first and then come back and substitute it with this expression to solve for my time. So my first step to solving this equation would be to subtract 42. So I'm going to this with just theta now instead of 2 pi over 3. And then my next step would be to divide 38. Okay. So now we would want to solve this. This is our ratio for cosine of theta. Well, this ratio is not on my unit circle, so I have to use my calculus to solve this. I want to solve this in radian mode. So I am going to go second, and I want to find my reference angle first. So I'm going to go second cos of 16 divided by 19. Whoops. And I get a reference angle of 0.5696. So now I'm going to look at my ratio, think about my cast rule. And when is the first time, remember I'm looking for the first time, when our cosine ratio is negative, which would be in this second quadrant. And I want to find this rotation angle. So they minus 0.5696. And I get a rotation angle of 2.57. So this would be my angle for theta. Now that I've solved for theta, I'm now going to replace theta back with this expression in terms of time. And so to solve for time, I'm going to take this solution for theta and divide by 2 pi over 3. So now I'm going to take this expression, I'm going to divide it by 2 pi over 3. And I get my answer, 1.228 minutes. This is in minutes. So in seconds, this would be a full 30 seconds. Or sorry, 60 seconds. And the decimal value of minutes into seconds. So approximately another 14 seconds. So a full minute and 14 seconds. So my answer would be 74 seconds. Okay, and that would be my solution. So to solve that algebraically, that is how you'd go about doing that question. If you wanted to check this answer, you could graph this function into your calculator, right? Go back to graph your function into your calculator, and then intersection point at y equals 10. So if we put this into our calculator, 38 cos of 2 pi over 3x plus 42, and then I want to see where this meets at the 10 meter mark. I'm just going to change my windows quickly to relate to, I'm just going to go to 6, 2, and we'll go up to 85 is our maximum height of our Ferris wheel. This is the point we are trying to look here. So if I go second trace, number 5 for intersect, move my cursor over here, enter, 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 I should get the exact same value, 1.228, which is what we got algebraically, and then change that to seconds would be 74 seconds. Okay, and so that is real problem trig functions, real world using an algebraic approach.